Aldehydes. Aldehydes contain the formal group, which is a double bonded oxygen bonded to a carbon, which is also bonded to a hydrogen. Because there's only one possible bonding spot for another carbon, these are always found on the end of a carbon chain. So these are on the terminal carbon. So these are always at the end of a carbon chain. Naming. So identify the longest continuous carbon chain containing the formal group, and this becomes your parent or root. In your name, you drop the E off of the alkane and add AL. And this is your suffix. We don't need to include a number here because they're all on carbon number 1. Priority is given to your functional group. So because this is on the end of the carbon chain, it's carbon number 1. Identify any prefixes based on any side groups that are present and their position relative to the formal group. This small aldehyde, here's the formal group. The longest carbon chain here is 1, so it's methanal. Now for this compound, we've got to identify the functional group. Here's our formal group, so it's an aldehyde, and we also have a side group that's a methyl. So our longest carbon chain here is 4 because you include the formal group carbon. So we've got butanal, because it's 4 carbons with an aldehyde, and we have a methyl group on carbon number 2. So this is 2-methyl butanal. So drawing. Identify the longest continuous carbon chain from the root, from the name. Put the formal group on the end. And place any side groups accordingly. So, ethanal, the root here is ethane. The Al indicates it's an aldehyde. So 2 carbons one of them has the formal group and the other one has hydrogens. Methylpropanyl. So this is telling us that our longest continuous carbon chain is 3 and that we have a methyl group, but it hasn't told us which carbon it is on. And the reason being is because it's redundant. There's only one carbon that the methyl group can possibly be on, and that is carbon number 2. If we had a methyl group on carbon number 1, that would make our longest carbon chain 4, which would make this butanal. So the methyl group goes on the second carbon, and the rest of the bonds are attached to hydrogen. So once you get higher than four carbons or higher, so it's 4 carbons or higher, you have to indicate with a number where your side groups are. Our physical properties. The carbonyl portion of our formal group is polar. It can also accept hydrogen bonds from water due to its lone pairs of electrons on the oxygen. So it can't form hydrogen bonds with water, but it can accept them. Therefore, small aldehydes are soluble in water. Well, it's basically between 1 and 4 carbons. As the chain increases, maybe up to 7 carbons, they're only slightly soluble. Once you get higher than that, that nonpolar portion of the carbon chain actually makes them insoluble. Aldehydes are very pungent, so very strong, not very pleasant odor for small chains. But the longer chains are actually quite pleasant. In terms of boiling points, the boiling point is higher than their corresponding alkanes. But lower than the same size alcohols. They have, for intermolecular forces, we have London dispersion force and dipole-dipole. Therefore, the forces of attraction between the molecules is stronger than they are for alkanes, but not as strong as they are for alcohols. Only methanol is a gas at room temperature. The others are liquids.